In this video we're going to be going over the theorem for side-side-side similarity, and it's going to be theorem 1.027. So the way that we state this is, so let me underline this first. Given a correspondence between two triangles, or between, not two triangles, the vertices, between the vertices of two triangles, or a triangle in itself, we say that if the ratios of corresponding parts corresponding sides are equal, then the triangles are similar. And this proof's going to be a little bit longer than most of them. So for the proof, we'll say that given triangle ABC and triangle DEF, such that A over D equals B over E equals C over F. Let's go down here before we start drawing this. So we'll get these two triangles. This one will be DEF, so DEF. And then this will be our smaller triangle, ABC. And then we'll label all the sides. We have lowercase letters for sides across from their vertices. Well, by segment construction, there exists some point, we'll call it point G, which is an element of the ray ED, such that C equals EG. So we'll label point G. We'll say it's about right here. So this length right here is C. Then we'll say that we can let L be a line through G parallel to DF. So we have this line going through G and it's parallel to DF. Make that F a little bit more clear. let's see, we'll make a claim. We'll claim that L intersects EF at some point H. So we want to find out if this point H is a real point or not. Well, we're going to do this as a proof by contradiction, so suppose not. Then L is parallel to EF. Also, L is parallel to DF, because those two lines were parallel to each other. Then EF is parallel to DF. But this is a contradiction. Ignore what I said a minute ago. I said something wrong about EF and DF being parallel to each other. And that's a contradiction because they intersect at F. So L does not intersect EF. Oh, this symbol right here means therefore. So L does not intersect EF at some point H. Since L is parallel to DF, we can say that angle EGH is congruent to angle D, and that's by corresponding angles. We can say that by angle similarity, triangle GEH is similar to triangle DEF. Then, by definition of similarity, C over F equals GH over E equals EH over D. Then remember what we have up here. So GH equals B. We'll say then. So then GH equals B, and EH would be equal to A. Then triangle ABC is congruent to triangle GEH by side-side-side congruence. And that's the end of our proof. Actually, I'm wrong. That's not quite the end of it. We do need to say a little bit more. We can say that then, if I can choose the right color, then triangle ABC is congruent to triangle GEH, And triangle GEH is similar to triangle DEF. So by, we'll just call it the previous theorem, which was theorem 1.026, triangle ABC is similar to triangle DEF. And now we're done with the proof.